The universe is enormous, and our solar system is only a tiny part of it. The breadth of the initial photos from James Webb and the interstellar travels of Voyager 1 and 2 show that the universe is vast beyond the solar system. However, the HelioPause has recently suffered many terrifying changes, and it appears that something is attempting to enter our solar system from interstellar space. In today's video, we'll discuss the alarming new threat found by the James Webb Space Telescope as it approaches our solar system. The HelioPause is the boundary between the solar system and the interstellar medium. The HelioPause is the boundary between our solar system and the rest of the universe. Therefore, shifts in the HelioPause are of particular interest to researchers at Long Peak. But our current HelioPause models don't account for certain terrifying changes that new research suggests. The alterations were uncovered through a review of data collected by NASA's Interstellar Boundary Explorer, IBEX. According to specialists, the HelioPause was detected by IBEX after the satellite picked up a series of increasingly energetic neutral atoms. Moreover, you are correct. This is a major development. Further, the HelioPause has shifted, as seen in the Voyager 1 and Voyager 2 data. Scientists found that the HelioPause changed so drastically between the times Voyager 1 and Voyager 2 entered interstellar space that it directly conflicts with our present understanding of the solar system's outer boundary. These sudden changes could also explain why the two probes are separated by such a large margin as they enter the interstellar medium. In October 2022, researchers wrapped up the paper on the topic, publishing it in Nature Astronomy. In it, they outlined how the scenario would evolve and categorized the HelioPause adjustments as potentially controversial. Therefore, they plan to continue exploring the farthest reaches of our solar system with NASA's Interstellar Mapping and Acceleration Probe to gain a more in-depth knowledge of interstellar space and a better grasp on these alterations. Scientists, however, will need to make do with the information we already have, including the results from spacecraft like the Voyager probes and the James Webb Space Telescope. But have you ever given any thought to how the HelioPause was first discovered? If you don't know the background, we'll fill you in. Once the heliosphere was discovered in the early 1950s, the HelioPause was a natural consequence of the space age's dawn. Once the heliosphere was proven to exist by satellite data, physics models of its interaction with the interstellar medium showed without a doubt that the HelioPause must exist somewhere. Pioneer 10 and Pioneer 11 are the most likely candidates for the earliest spacecraft. As a result, evidence for the HelioPause began to emerge. Years of data on solar wind activity have been gathered by the Pioneer probes since their 1972 launch, extending to nearly $67 away. However, Pioneer 10 sent its final coherent signal back to Earth in January of 2003. In 1993, however, data from the Voyager spacecraft confirmed the existence of the HelioPause with greater certainty, in addition to providing the first direct evidence of a definable boundary with interstellar space. The two probes were in a privileged position in the interstellar medium to detect strong low-frequency radio waves generated by the violent interaction between intense solar winds produced in May and June 1992 and the interstellar medium. However, the discovery that galactic cosmic rays had increased while solar wind particles had decreased was made by Voyager 1. The most convincing evidence for the HelioPause's existence came in 2012. The signal proved that Voyager 1 had entered interstellar space. Despite the seemingly clear evidence, the anomaly wasn't isolated to Voyager 1. In 2018, Voyager 2, which is on a far different trajectory than Voyager 1, saw the same rapid drop in solar wind particles and spiking galactic ray particles. Let's discuss what an asymmetric HelioPause actually is and why scientists are so worried about it. A good analogy for the HelioPause, if we are to conceive of it as a boundary, would be a windsock that is continually being stretched and blown outward by the wind. Let's assume that this is the shape of the HelioPause from a purely physical standpoint. A comet that is nearing the Sun and is generated from the sublimation of gases surrounding the comet's core is another close approximation, and that's how the HelioPause appears in your mind's eye. This means that the HelioPause has a specific form that happens when the solar wind collides with the interstellar gas and magnetic fields outside the heliosphere, which exert an opposite force. In addition to the force of the interstellar wind on the heliosphere, the reversal of the Sun's magnetic field polarity throughout the course of the solar cycle contributes significantly to the shape of the HelioPause. When the solar wind pushes up against the interstellar wind, It causes a three-dimensional sine waveform in the solar wind, which in turn affects the formation of the heliosphere and HelioPause. The only artificial objects known to have entered interstellar space so far are the Voyager probes, which crossed the HelioPause in 2012 and 2018, respectively. Their observations were critical in establishing the existence of the HelioPause. But it is evidence that a system consisting of only two sensors cannot accurately detect a three-dimensional structure in space. However, what we should be worried about is the asymmetry of the HelioPause, which might lead to an invasion of extraterrestrial life. While it's obvious that interstellar space lies beyond the HelioPause, much more regarding the HelioPause and what lies beyond is still unknown and up for debate. For a long time, scientists have speculated about the existence of a bow shock just beyond the HelioPause, where solar wind particles and the heliosphere's magnetic field disrupt, but do not completely overwhelm the interstellar medium in front of them. The theory of a softer bow wave has gained acceptance due to the contention that the solar system is not moving swiftly enough over the interstellar medium to cause a shock. The ibex ribbon is a band of intense ENAs that extends along the heliosphere and is notably brighter than the neighboring ENAs, presenting a contrast. Nonetheless, no one has yet provided a satisfactory explanation for the occurrence of the ibex ribbon or its implications for current HelioPause models. A research student at the Southwest Research Institute named Justina Sol has argued that the Sun is similar to billions of other stars in the universe, suggesting that some of those stars have atrophied like the heliosphere. But only this atrophy is one that we can observe closely because we are truly inside. Consequently, we need to fill in our knowledge gaps regarding the local area before expanding our horizons to the rest of the universe. However, imagine a world where there is no HelioPause to protect humanity. We humans are ridiculously fortunate to have that solar windshield. The heliosphere, which the Sun provides, absorbs 70% of the interplanetary cosmic rays. Without the heliosphere, cosmic rays would collide with Earth, interacting with it in a way that would greatly increase the radiation we absorbed, frying life on the planet like eggs in a pan. To the contrary, it is not known how challenging this wall of hot plasma will make interstellar travel if and when we decide to journey beyond Mars and finally exit our solar system. Even so, considering that Voyager 1 and 2 arrived safely, at least our interstellar ships don't look like they will take too much of a hit. We don't know how the plasma wall will affect living beings like us. Thus, this is a topic for further discussion. The study of the HelioPause, as well as interstellar space in general, is crucial for expanding our understanding of the cosmos. As humanity continues to send probes into space, one of the key goals is to learn about the boundaries that define our solar system and how they interact with the surrounding interstellar medium. This information could have profound implications for our knowledge of other star systems and the environments they harbor. The HelioPause plays a critical role in protecting life on Earth by shielding us from harmful cosmic rays. These high-energy particles, originating from outside our solar system, can have a variety of damaging effects on living organisms, particularly in space. In addition to the HelioPause, the Sun's magnetic field serves as a natural barrier, deflecting these particles and helping to maintain the delicate balance of conditions that make life on Earth possible. However, the changes in the HelioPause observed in recent years raise important questions about whether this protective barrier could be weakening or becoming unstable. The fact that the HelioPause is not a perfectly defined boundary adds to the mystery of this region of space. As new data from the Voyager probes and the James Webb Space Telescope continue to come in, scientists are working to refine their models of the HelioPause and how it behaves. This is particularly important because we are still in the early stages of studying interstellar space, and the information we gather now could serve as a foundation for future exploration. Space agencies such as NASA and the European Space Agency, ESA, are already planning new missions to study the outer reaches of our solar system and beyond. One such mission is the upcoming launch of the Interstellar probe, which aims to travel farther than any spacecraft before it. The Interstellar probe's primary mission will be to explore the outer boundaries of the heliosphere and beyond, taking measurements of interstellar particles and magnetic fields. This will provide researchers with valuable information about the structure of the heliosphere and how it interacts with the interstellar medium. The probe will also measure the properties of cosmic rays and study how the Sun's magnetic field behaves in this distant region of space. As we learn more about these phenomena, we will also gain insights into how our solar system fits into the larger context of the galaxy and the universe. Despite the many challenges that space exploration presents, we are making significant progress in understanding the dynamics of our solar system's outermost regions. Space missions like those involving the Voyager and New Horizons spacecraft have already provided us with unprecedented views of the outer planets and their moons. For example, New Horizons' flyby of Pluto in 2015 expanded our knowledge of the dwarf planet and its moons, revealing complex surface features and a dynamic atmosphere. Such missions pave the way for future probes that could travel even farther, gathering more data about distant regions of the solar system and interstellar space. In addition to understanding the HelioPause, space exploration offers the potential for other groundbreaking discoveries. The study of exoplanets, for instance, has exploded in recent years, with thousands of new planets discovered outside our solar system. Many of these planets exist in the habitable zone, the region around a star where conditions could support liquid water and possibly life. As we continue to learn about these distant worlds, we gain a better understanding of the potential for life elsewhere in the universe. Some researchers have even speculated that extraterrestrial civilizations could exist beyond the HelioPause, and that someday we might make contact. One of the most exciting prospects for space exploration in the coming decades is the possibility of human missions beyond our solar system. While this may seem like science fiction, recent advances in propulsion technology are bringing us closer to this reality. Concepts such as the Breakthrough Starshot Initiative, which aims to send tiny, lightweight probes to the nearest star system, Proxima Centauri, are already in development. By using powerful lasers to propel these probes to a fraction of the speed of light, we could send them on a journey that would take only decades rather than centuries or millennia. These probes would be able to capture data from distant stars and planets, offering us a glimpse into the farthest reaches of the universe. Another area of space research that has garnered significant attention is the study of dark matter and dark energy. These mysterious substances make up approximately 85% of the universe's mass, yet we have little understanding of their nature. Scientists believe that understanding the HelioPause and the interstellar medium could provide valuable clues about the nature of dark matter and dark energy. In particular, studying the interactions between cosmic rays and the solar wind could shed light on the behavior of these elusive substances and how they influence the evolution of galaxies and star systems. As we look to the future, it is clear that space exploration will play an increasingly important role in shaping our understanding of the universe. Whether it's the ongoing study of the HelioPause, the exploration of distant exoplanets, or the pursuit of interstellar travel, the discoveries made in the coming years could redefine our place in the cosmos. The challenges are immense, but so too are the rewards. Every new mission and breakthrough brings us one step closer to answering some of the most profound questions in science and unlocking the mysteries of the universe. As humanity's technological capabilities advance, we may even find ourselves looking beyond our own galaxy. The Milky Way is only one of billions of galaxies in the observable universe, and each of these galaxies contains millions, if not billions, of stars with potentially habitable planets. The discovery of life beyond Earth, whether microbial or intelligent, would be one of the most transformative moments in human history. For now, our focus remains on understanding the limits of our solar system, with the hope that this knowledge will eventually serve as a stepping stone for more ambitious endeavors. In the coming years, space missions will continue to evolve, offering new insights into the HelioPause and other phenomena in our solar system. As we send spacecraft farther and farther into the void, we will gain an increasingly detailed understanding of the forces that shape the universe and the potential for life beyond our own planet. It's an exciting time for space exploration, and the discoveries that lie ahead could change the course of human history forever.